12.9. Okay, so this is an assignment about once a week. I give you a big one. It has a bunch of free response questions on it. Good practice. So we'll probably split this up and do like three. Try the first three before you watch this video, and then I'll go over how to do them. Talk about the scoring, and then we'll try the next three. So we'll probably spread this over a couple days. But you could start on it today if you haven't. So try these problems if you haven't. We're going to just try the first three though, and then watch this video. Now, graphing calculator problems, I generally try and let you know what they are. They're usually the first two problems, problem 1 and 2. Now, sometimes I rearrange these problems. I keep the problem numbers, original problem numbers on them, so then you can tell. So let's see. Let R be the region in the first quadrant bounded by the graphs of this graph and this graph. So let's see. I would draw a picture. You do have a graphing calculator. I think you guys should be able to graph these without having to do that. You can do it if you need to. First quadrant. So we're kind of focusing in on this section. And this drawing is not going to get you credit. It's just going to help you set things up. So square root function is the top half of a sideways parabola. And then x over 3 goes through 0, 0, and has a slope of 1/3 up 1 over 3. So it's probably something like this. Now, you could graph it to verify, but the sideways parabola is going to have an infinite slope at first. So it's definitely going to be above this steeper, and then it kind of comes across. We got to find these intersections. This is 0, 0 for both of them. This one, we could try and do it by hand, which might be quicker than using the calculator to do it. We got to get rid of the square root, so you square both sides. And then you could get rid of the fraction, and then you could move everything to one side. Sorry, minus 9x equals 0, and then you could factor. And this wasn't bad. X equals 0, which we already saw, and x equals 9. So this should be 9. An easy way to check it is to plug it into both functions, and that should give you the y value. 9 over 3 is 3. Square root of 9 is 3. Looks good. Okay, this is the region we're trying to find the area of on part A. So we could do vertical slices. Y top minus y bottom, which looks easy enough. So probably be the easiest, quickest way. So we're going to integrate from left to right, 0 to 9. And y top in terms of x is the square root of x function minus y bottom dx. And we have a calculator, so for sure I'm going to use my calculator to do any integrals because that's going to save us a lot of time. And we could put these functions in the y menu. They're not that complicated, so I don't know how much time that'll save us. But go math 9. You could do vars, y vars function y1 minus vars, y vars function y2. Make sure you remember where you put them. Maybe write a little note to remember it. Comma x, comma 0, comma 9. And I'm waiting for it. 4.500. I bet it was supposed to be perfectly 4.5, but my calculator is using estimation techniques, so pretty good. Let's see if just for the practice of it, because sometimes you might have to do this. Let's see if we can do horizontal slicing. X right minus x left. We're going to integrate bottom top, bottom y value to top y value. And it's going to be x right. Now, x right is the line, which would be 3y. X left is the square root, so that's going to be y squared. So it's going to be 3y minus y squared dy. So not that hard to set up. Let's try it. Math 9, 3x minus x squared, comma x, comma 0, comma 3. And wow, it came out to exactly 4.5. Now I'm just going to add the extra zeros just to indicate my intention of the accuracy of my answer. Now, point-wise, 1 point for the limits, 1 point for the integrand, and 1 point for the answer. So, B, find the volume of the solid generated when R is rotated around the vertical line x equals -1. Now, we could try and use this drawing right here. Say, all right, x equals -1. It's going to get rotated. I'm just going to kind of squeeze it in there just so I don't have to draw another picture. Now, we're going to find the volume of it. It's rotated around x equals -1. We do vertical slices. Those are going to be parallel to the axis rotation, which are going to give you shells. So dx is going to give you shells. The volume of a shell, if you slice it open, forms a rectangle. 2 pi r. The circumference of the shell is the height of the rectangle. H, the height of the shell, is the height of the rectangle. Dx, and then we're going to integrate. So we're going to do 2 pi. We're going to integrate left to right on the original region, 0 to 9. The radius is x right minus x left. X right is whatever x we're at, minus x left is -1. So the radius of shells is usually just x or y plus or minus a number. It doesn't involve the curves. The height involves the curves. It's y top minus y bottom. Y top in terms of x is the square root of x. Y bottom is x over 3 dx. That's your setup. And then you can use your calculator to get your answer. If you want to do, so let's go ahead and just do that on our calculator real quick. 2 pi math 9 parentheses x plus 1 parentheses square root of x close parentheses on square root minus x over 3 close parentheses comma x comma 0 comma 9. And so our answer is 130.061 or 130.062 if you want to round. The other way of doing it is with horizontal slices, and those are perpendicular to the axis rotation, and they're going to give you these washers. So it's going to be pi big R squared dy minus pi little r squared dy is the volume of one slice, and then we're going to integrate them to get all the slices. The limits, so we do it right here. This is our big R, and this is our little r, and they're x right minus x left. X right minus x left. And we're going to integrate in the y direction, so 0 to 3. The big radius is x right, which is that line in terms of y is 3y minus x left, which is -1 squared dy minus pi 0 to 3. X right here is going to be the x coordinate on that square root of x function. So that x equals y squared minus x left is that axis of rotation, -1 squared dy. So that's our setup that way. So let's see if we get the same answer. Pi math 9 parentheses 3x plus 1 squared comma x comma 0 comma 3 minus pi math 9 parentheses x squared plus 1 close them squared again comma x comma 0 comma 3, and hopefully we get one. Oh, there we go. So we got 130.061 or 130.062 points for this one. I don't have them written down, but I bet that the answer was a point, and the limits and the constant might be a point, like not making sure you get the 2 pi and limits right, and then the integrand might be a point. something like that. C, let region R be the base of the solid for the solid cross sections perpendicular to the y-axis or squares. Find the volume of the solid. So this is volume by cross section. So I'm going to just draw these again real quick. And this is the square root of x, and this is x over 3. And so they're going to be, this is the base of your 3D shape. And so, but they said that they're perpendicular to the y-axis, which is kind of rare. Usually they are vertical. But draw one slice. They're squares. Okay. And so we're trying to get the volume, some area for all the cross sections in terms of y, dy. They are squares. They are side squared. And so our limits are going to be the y direction, 0 to 3, bottom y to top y. The sides right here are x right minus x left. In terms of y, x right is that line which we wrote up there was 3y, and x right is the line, x left is that's y squared. So that's what's going to go in here, 3y minus y squared dy. That's our setup. And I guess we're supposed to calculate it. So we'll do math 9, parentheses, 3x minus x squared, close parentheses, squared, comma x, comma 0, comma 3. And we get 8.1. So probably a point for the integram, probably a point for the limits, probably a point for the answer. So I don't know. I hope you guys are getting pretty good at these area volume problems. We've done them most recently. You're getting a lot of practice with them. Usually one of the 6 free response questions involves area or volume. I'd say the more current AP questions aren't as straightforward as these involving area. They make them a little tougher, and I'll show you guys some of those. But you got to be good at these straightforward ones before you can venture into some kind of more twists and stuff. All right, let's try the next one. Hopefully you've tried it already. And this is a graphing calculator problem. And at first glance, hopefully you're getting to a point where you start to have a good idea of what kind of problem it is. There's really half a dozen, 6 kind of major kind of problems that seem to show up on free response. Area volume problem, graph of the derivative, differential equation, one-dimensional motion, rate model. Sometimes, I don't know, those are some of the ones. Usually there's one with a table in it, usually one with the graph, usually one with an equation. Water tank Camp Newton holds 1,200 gallons of water at time 0. So that sounds like an initial condition. During the time interval 0 to 18, those are your endpoints, water is pumped into the tank. So I like to put a plus next to it. During the same interval, water is removed from the tank. Let's put a minus next to that. And so this is rate model, isn't it? So I'm going to write my rate model just to have it. So the rate model is the amount at time t is the amount at time 0, which is 1,200, plus the integral, the accumulation of all the positive changes. So W2 is a rate. It's positive changes. So 0, whatever time this is at, to t of W t dt minus 0 to t of RT dt. So there's your rate model. I might not actually use it the whole thing right away. A is the amount of water in the tank increasing at time 15. Why or why not? So if something's increasing, that means its derivative is positive. So we want to show A prime at 15 is positive. or negative or whatever. So let's find A prime. So A prime of t equals, you just wrote your rate model, WT minus RT, which makes sense. It's going to be the incoming rate minus outgoing rate. That's going to be the overall rate. So I think it's good to write this down, and then we're going to write 15 down, label your work, show these things, write these things down. Now I'm going to get these values from my calculator. Now, before I do anything else, I have a feeling I'm going to be using these equations multiple times, and they're pretty crazy looking. So I think it's definitely worth it to type them in. 95 square root x, close parentheses and square root. I'm going to put parentheses around the sign because this is sort of the lazy way of writing sine squared. But I don't, that's the same thing as all of that squared, right? So sine of x over 6, close parentheses squared. Okay, so that's that one. And the next one is 275 parentheses sine x over 3, close squared. Okay. Now I could go to the table if I just want to calculate some values and put 15 in there. And there's WT at 15. It's 131.78210. And R15 is, now remember, if you highlight them, you get a more accurate version here because it's not even 3 decimal accurate right there. It only displays 5 digits in the table, and it rounds the last one for sure. So highlight it, look at the bottom, you get a more accurate version, 252.872.335. Now I'm going to go back to my home screen and calculate what that is. 131.782.310 minus 252.872.335 equals negative 121.090025. You need to have these values somewhere in your work to support your answer. Now, it clearly came out negative, so it's actually decreasing. And that's because the overall, rate is negative. Or you could say the rate that water is being removed is greater than the rate that water is being pumped in. Therefore, it's decreasing. But you'd have these values here. You would reference these values in your work. So I'd say no, the amount of water in the tank is decreasing at t equals 15 hours since W15 minus R15 equals negative 1.21, negative 121.090. We can even put the units here. Gallons per hour is negative, something like that. Or you could say, since the rate of water being pumped in is all right. Point. I didn't write down the points for this. It's probably like 1 point. To be honest, probably 1 point. Okay. Maybe 2 at the most. B, to the nearest whole number. Now, this is something you got to watch out for. To the nearest whole number, how many gallons of water are in the tank at time 18? So we're always doing 3 decimal accuracy, which is always by default what you should do unless they tell you something else. And when they tell you something else, it's easy to just not even see it. And even if you see it, it's easy to forget it. So we need the amount of water at time 18. That's the whole rate model. So we get to use our rate model now. The amount at 18 is 1200 plus 0 to 18 WT dt minus 0 to 18 RT dt. Now, one of the things that I just want to point out again is you can just write WTRT in your setups and get full credit. You don't have to write the crazy equation. They named it W and R, so you can use their names. This is the setup, which is probably going to be worth most of your points on here. And then we're going to use our calculator. And we're going to do 1200 plus math 9 vars, y vars function y1, comma x, comma 0, comma 18, minus math 9 vars, y vars function y2, comma x, comma 0, comma 18. Hit enter. And, take a deep breath. If your calculator is slow like mine. 1309.788183. I'm going to just write all that down just in case I need that for some other calculation. It's going to save me a lot of time than having to redo it. And I'm going to write the answer. There are 1310 gallons of water in the tank at time t equals 18 hours. So remember to round to the nearest whole. Now, the points here, point was for the limits, point was for the integrands, point was for the answer. Now, if you didn't round the answer to the nearest whole gallon, you lost that whole point. So that would stink. C, at what time t, 0 to 18, is the amount of water in the tank an absolute minimum? Show the work leads to your conclusion. Okay, so that's EVT, right? So we're looking for absolute min of A, 0 to 18. So these are your endpoints. And we're going to do EVT. So let's show all the work very carefully. How do we find critical points? And you might even make a point like, okay, these are critical points. You take the derivative of the thing you're trying to maximize. And A prime is WT minus RT. And you're going to set it equal to 0 or undefined. This is often worth a point on these EVT problems for response. And if you don't write A prime equals this equals 0, you lose that point, even though I guess you're doing it in your head. But this is like serious calculus right here. Now, finding the answer, that's like algebra. The way I'm going to find the answer is, you could create a new equation, or you could say, oh, this means that WT is going to equal RT, right? Which is a result of setting the derivative equals 0. And so I'm going to graph these. Now, before I graph it, I go to the window, and this is 0 to 18. And then I'm going to go zoom fit, because I don't really know how tall these graphs are. And this takes a little extra time because it pre-calculates all the y's for your X window and then resizes the graph to fit them perfectly. Now, the first one is Y1. So that's the incoming rate, the pumped into. And then the second one is the removal rate. So you could tell, you don't need to sketch this, but here we're removing more than we're coming in. So the tank is going down. Then the amount of tank is going up. So this is actually a relative min. And then the tank is going down. So that's a relative max, which is probably going to be your absolute max. But we got to show all the work. First thing we need to do is find the intersections. Second calc, number 5, first curve, second curve. Now this is 0 to 18, 0, 1, 2, 3, 4, 5. Looks like there's one near 5. And it'll be blinking on it, so you know which one you found. So T equals 6.494842. And then we're going to find the other one, second calculate, number 5, first curve, second curve. This is more like 12 or something. 12.974825. Now, do they intersect over here on the edges? You just want to make sure you don't miss something. So we could do second calculate, number 5, first curve, second curve, and guess like 1 and see which one it finds. It'll either find 0 maybe, or it'll find this one. If it finds this one, okay, 0, 0. So 0 is, I guess, the critical point. Second calculate, intersect, first curve, second curve. Now this goes to 18. I mean, you could do 17.5. Now it's going to try, if there is one, it'll find that one. It'll find the one that's closest to your guess. Otherwise, it's going to find this one, which is further away, which means there wasn't one over here. Wow, I found that one over there. It's kind of weird. Anyways, okay, so we have our critical points. We're going to make a table, organize our information, put the T's in, put the endpoints, put the critical point 6.4948402, 12.974825, 18. We're going to plug them into our rate model, which I'm going to write right here so that this is more of a reference for me. I mean, you just put AT, but I just like to write it there just to make sure I'm doing the right thing. Now, if you plug 0 in, you should get 1200. They had us find 18 already. Isn't that what we just found? So don't recalculate it. Sometimes some of your previous answers might be part of the work for another answer, so don't redo it. So we just got to do these. Now, on the home screen, I think I had done this last one just recently, and you're like, oh, I cleared my whole screen. I can't use it. No, hit second enter, and it'll bring up your last calculations. Hit second enter again. It'll bring up the second to last one. This is exactly what I want, but I want to put 6 point. Now I'm going to do second insert, and it'll start pushing everything over so I don't have to retype it. 4948402. And then over here, 6.4948402. And this should give me the amount here. And then I'm going to do it again for this other one. So this is 525.242152. Second enter. So here I'm going to put 12.974825 and then 12.974825. Hit enter. So it's good to take advantage of all that work you've done, because that's, some good time savings. What we're going to get now, I think this is going to be it. 1697.441236. So I told you guys before, I thought that's going to be the one. Well, that's the max. Be careful. I almost made a mistake. They want the minimum. So here's the minimum. Please, don't lose points because you answered the wrong question. So now I'm just going to put this into words. I'm going to say the absolute minimum amount of water in the tank is 525. Now, did they tell us to round to the nearest whole gallon here? They don't, so I'm going to go with 3 decimal accuracy. 242 gallons, put units, at time t equals 6.494 hours. Okay, so that's the answer by extreme value theorem. And how does extreme value theorem work? By checking endpoints and critical points. Nice thorough answer, just in case. Now, did they want the amount? They wanted the time, but we gave them that with everything else. So that's probably a good amount of points. 1 point for finding the critical points, 1 point for your supporting work, 1 point for your answer and justification. So at least 3 points there. You guys should be so good at extreme value theorem. I've been making you guys do that forever. D. Now D is, I think, 2 points. 2, 3. This is probably, first one's probably 1. So this one might be 2 or 3. Okay, so part D, for time greater than 18, okay, this is new territory. No water is pumped into the tank. Done pumping in. Water continues to be removed at the same rate RT until the tank becomes empty. Let K be the time at which the tank becomes empty, right? But do not solve an equation involving an integral expression that can be used to find the value of K. So you're going to set a problem up, an equation, which should have two sides, something equals something else. It should have integrals in it. It should have K in it. Okay. And it's for everything beyond time 18. So let's see. We're trying to figure out when is the tank empty. And we're going to call that K. So this is, we say, well, when is the tank empty? That's when the amount in the tank is 0, right? Equals. Now, there's different ways to set this up. We could say, well, let's take the amount at 18, 1309.788, and then keep subtracting the removal rate, RT/dt, but starting at time 18, because this is the amount at 18, so this should start at 18 to the K value. So here's your equation, left side, right side. AT doesn't count as the left side. It's got to be like numbers and expressions. That's your equation involving integrals that can be used to solve K. That's one way. You could also simplify this and say, or you could think of it just in a different way. You could say, how long does it take for the removal, or when does the removal equal the amount of water in the tank at time 18? Because that's when things change. So you could do it like that. You could say 0 equals, and start with the initial condition 1200 times 0, go plus 0 to 18 of the pumped into rate, 0 to 18, but it stops at 18, minus 0 to K of the removal rate. This works. Okay. So there's a bunch of different ways to write it. But don't solve it. One, I just don't think you can. And even if you can, you don't want to. Because even if you do, and you make a mistake, that could be held against you. And it's definitely been held against you that you're losing time because of it. Okay, the next problem that you should have tried, and this will be the last one we're going to do right now. So it's good, rate model. We're jumping to problem number 4. So the order of these is a little different. Actually, there's only 4 problems. Is that true? Just 4 problems? So we'll take a break there then. And then we'll do the other 2 in a separate video. Okay.